kind of go over how we're going to use Joy to implement server validation, and just kind of refreshing as well some of the stuff we just saw in the video about what it is and why do we need to do it. So as we were previously kind of talking about, clients there, you can do client-side validation or you can do server-side validation. Generally, when you're doing client-side validation, that's going to be implemented in JavaScript and or HTML. So remember, he mentioned that you could say like type is equal email. That would do one thing as far as validating that something is an email. You could also do things like the minimum length of this field is 3, so saying that they have to put 3 fields at least 3 characters in there, or mark it required to make sure that they put in a value. Cool.
Yep.
So you remember the bunch of HTML attributes, and we can, this is one way, and we can also use jQuery and vanilla JavaScript to do that validation as well. That provides really quick feedback to the user, and in general, it reduces the number of HTTP requests that the server has to handle. So it gives the user quicker feedback, but it also ends up making our servers faster, our application faster, because those aren't a request that the server has to handle. They get handled on the browser instead of pushing that additional request to the server. So that means we can do things like a validate immediately after they leave the field, rather than waiting until they submit the form. Because if we tried to submit it every time they leave a field, every time they enter one field, that would be a big hit on the server. Does that make sense?
Yeah.
Or you can do things in response to, key down and say when they press a key, immediately go check that the email is valid, rather than waiting to they go all the way to the end and they submit it. So some websites you'll see that where it immediately tells you as you're typing the email whether or not it's valid. Paul, did you have something? I'm guessing not. So that's kind of the benefits and the reasons that we do client-side validation. We can also do server-side validation. That's really important. It's a must-have for security reasons. We really want to make sure that we don't trust our user inputs, because they might have left something out. They might have put the wrong thing in. They might actually be trying to break our website. There's more than one way to attack a website by using the forms maliciously. So anytime we have a form, we have to also assume that a hacker or some sort of malicious attacker might be wanting to use that to do all sorts of things with our website, whether that is putting in spam, whether that is trying to steal credentials from other people, or possibly even deleting data from our database. There's a lot of things that can go wrong if we don't deal with the data or the user inputs well. So one part of the server validation is to make sure that invalid data doesn't get into the database. The other part is making sure we sanitize the data to prevent security problems. So some common security problems that can come in if we don't properly sanitize our data from at the beginning can be SQL injection and cross-site scripting, shorthand known as XSS. These can both be ways for things to go wrong. Okay. Any thoughts at this point?
What's cross-site scripting?
I'll talk about it I've got a slide about SQL injection and a slide about XSS, so we'll talk about that in a minute. Any questions beyond that?
Nope.
Okay. So let's talk about SQL injection first. So you may have heard of a comic called XKCD. They did a really good strip on what it is and what it can mean and where is it problem. We can kind of look at what we have here. You've got the mom kind of responding to a call from the school. Hi, this is your son's school. We're having some computer trouble. Oh dear, did he break something? And they respond in a way. Did you really name your son Robert, quote, parentheses, semicolon, drop table students, yada, yada, yada. You should notice that this looks a lot like SQL, right?
Yeah.
So basically, if you think about, the context here, they're registering a student, right? And there's probably a SQL database behind there, and so, for his first name, rather than putting a nice, just good first name like Robert, something malicious went in there, right? So come back to, you can kind of guess what's going on here. Oh yes, little Bobby tables, we call them. We've lost this year's student records. I hope you're happy. And I hope you've learned to sanitize your database inputs. So what happened here? Well, what happened was they entered the student's, first name blindly. Probably she registered her child on some sort of website, and now all of their records for the year are gone because they dropped the students table. Does that make sense?
Yeah.
So you have to be very careful about how you deal with data. You remember the first way that we kind of started doing and working with SQL, right? What did we do? We used string concatenation or templates to put the data in there.
Yeah.
And you can imagine that if you're using either string concatenation or templates, this is a really common thing that you can get yourself into, in the sense that, what happened was you basically terminated that statement. The statement was wanting to, insert the first name, so you gave it that, and then you went ahead and added another statement after that, and that's where the semicolon came in to start a new statement. So that's really something you really, really want to avoid. And so one of the things we don't do, right, we don't want to build SQL queries up with concatenation, for one. Anytime you're doing that, you're doing it wrong, because you have just opened the door to this, and it will eventually come back to bite you. Cool? So what tool are we using instead of writing SQL directly? What tool did I show you how to use? Connects, right? Which is a...
what do you mean, which is a...
What is Connects?
A library?
It's like a module?
What did you say, Troy? I couldn't hear you.
Library?
It's a library. Okay, what kind of library is it? If you look at the Connects page, it says it like in the first line of its description. What is Connects? So Connects is what we call a query builder, right? So it's a tool that we use to build the query. Does that make sense?
Yeah.
Build the SQL query. And one of the benefits that comes with that is it has better support for kind of dealing with things that might be SQL injection attacks. It goes ahead and deals with some of those issues that can come about. We still need to be cautious. We probably still want to sanitize our inputs, but at least we'll take care of a lot of common kind of cases in terms of dealing with SQL injection attacks. So that's one part of our solution to how do we solve SQL injection, is we use Connects, which actually Connects in itself. Part of the way that that's also defeated is using something called prepared statements. And prepared statements, the way that they work, rather than just sending, here's a SQL query, go run this to the database, it says, well, here's a query with some pieces left out, right? So like maybe the first name is left out and said, here, put the first name here. And then we give the first name as a separate piece of data. And by using prepared statements, it knows what's code and what's data, and that way data like this doesn't get treated as code. Does that make sense?
Yeah.
So prepared statements are part of that, and the other part is using a query builder, but the query builder, as it turns out, gets us already into using prepared statements as long as we don't tell it to run raw SQL, right? So if we told with Connects, you can still tell it to run raw SQL queries, like just give it the select statement and say go run it, or the insert statement. But if you do that, if you give it raw SQL, you open yourself back up to this problem. Cool. So that's one thing, these are one of the pieces that comes into, doing server-side validation and making sure that we don't let the users just enter anything that may be dangerous. The other kind of attack that we want to prevent is something called a cross-site scripting attack. And the way that this works is that you have somebody on your website, generally through a form, puts in some sort of malicious data. Usually it involves either some HTML code or putting in some JavaScript code. JavaScript code being the more malicious of the two. So that generally involves them putting some code into a form, and oftentimes this comes up with posting things as comments, right, on social media or videos, putting things as comments or putting things as blog posts, and then people see the blog post and it runs the code, right? So XSS can be things like I posted, maybe your website is open for people to create their own blog and post a blog. Well, if you just let them run any code, then they can do a lot of malicious things as soon as that runs, even as soon as they see the post, right? So they open the post, and all of a sudden now maybe their profile icon's changed to something else, or they posted a bunch of comments over on somebody's, spammed somebody with a bunch of comments or whatever it may be. Or if you're especially not careful, maybe they've gone so far as changed your password because you looked at their post, right? So cross-site scripting is pretty malicious and pretty a broad problem in general, because if you can run code, right? If I can write JavaScript code that runs on your website, then I can do anything I want. Does that make sense?
Yeah.
So we have to make sure that we sanitize our inputs so that when this malicious data comes in, we do something with it. So they put the data in, we say, okay, that ends up into the database. Next time somebody else comes along, they make an entirely innocent request, as they say, which would be things like, hey, I just want to look at this blog post, or I want to read the comments that go with the blog post. And next thing you know, the server, because it saved the malicious response that was put in there, sends that malicious response back to the browser, and without doing any sort of sanitation, it just returns it verbatim. Browser runs that code, and your ship is sunk, right? Your security for your website is completely breached, potentially, or any sort of privacy, et cetera, et cetera, et cetera. Cool. So does that explain the question, Paul? You were asking what XSS is?
Yeah, I'm trying to picture how that would work in real life, though. Like, what that would mean, just other than a corrupted database. But yeah, I generally get the idea. It's malicious actors.
So it's not usually a corrupted database. That's not usually what this comes into. What this comes into is things like, you heard this term self-replicating. So like a self-replicating tweet or a self-replicating post. This can be things like I post a tweet on Twitter with some JavaScript in it, and then by me viewing that tweet, I then also send that tweet.
Oh, okay. All right. I think it's something like I've seen. There's some websites that if you have too much post activity. Like let's say you try to edit a forum post too many times within a certain amount of time, then it'll just lock you out for a while. Is
That's
that
not
kind of
that's
like what
not the
we're
same
guarding
thing.
against?
That's not the same thing at all. That's not XSS.
Okay.
XSS is injecting code, specifically generally JavaScript code, but it might also be CSS or HTML that you're injecting to make malicious things happen, and that's kind of where the gray area comes, because I say malicious things or make bad things happen because it can actually, once you can run JavaScript, it can be anything. You can do anything you want, including, we talked about how to use Ajax, right?
Yeah.
If I can put JavaScript out there, then I can run whatever Ajax request I want to, as soon as you view the thing.
How would you like inject
Okay.
JavaScript though?
Well, I would just write it into the field. Let's say you give me a text area, right?
I see.
I just, in the text area that you gave me, maybe it's a contact us form, right? You got a little text area on there, right?
Yeah.
Well, I can put whatever text I want into that contact us form, right, in the message.
Yeah.
If I decide to put JavaScript in there, right, well, if you're not sanitizing it, that's going to end up in your email box. And well, what if Outlook decides to run that JavaScript code, or that I think VB or Visual Basic script or whatever it is, right?
Yeah.
Then you're going to have a problem. So the point with cross-site scripting is you kind of enter some code in one place and it pops out in another place. That's where the cross-site parts. So it's, you enter it one place and then it pops out somewhere else. Usually your whoever you're attacking, you're not attacking yourself, you're attacking somebody else. But you oftentimes don't necessarily know who you're targeting. I mean, you might do it in, say, a direct message, and then it would be one-on-one, but oftentimes you're throwing a broad net and making things public. So the overarching way to defeat this, though, is to make sure that your user can't give you code. That makes sense. If you can prevent them from giving you JavaScript, or somehow prevent the JavaScript from being put onto the page, right, then you can block this. But if you just say, take the string that they have and put it out there. So one of the things where this comes up, you'll remember there was a video that I'd post. I don't know if everybody saw it, but there was a video I posted that's part of that series. There's a part of that series on handlebars, right? And it talks about what's the difference between the double curly braces and the triple curly braces. Does anybody remember what the difference between the double curly braces and the triple curly braces is?
I don't remember specifically, but triple curly braces means take the literal kind of like text value from the file that it's grabbing from.
Okay.
If you have double, it just takes because I know that if you put double, it literally puts your code word for word, but if you put triple, it pulls from the code what it needs.
So
right?
There's a little bit of misunderstanding there, because the one that pulls it literally is actually the triple bar. The double bar does not pull it literally. So the triple bar takes whatever you have and directly puts it on the page as it is. So for instance, if I have JavaScript code or HTML code or whatever in my field, right? Let's say I have a name and I've injected some HTML into my first name. That would run if I put it in a triple bar, it would run that as HTML code.
Yeah, it's like body. That's the only one that I've seen that we've done consistently so far.
That's the only one we're pretty much going to do. It's very rare that you want to use a triple bar, because as soon as you use a triple bar, you now are opening yourself up to XSS. So that double bar is actually it's a preventative measure for XSS, actually. So the double bar, the double curly braces, what it does is it strips out, it replaces any sort of special HTML characters with entity symbols. So for instance, if I have a less than symbol, right, which would be the start of a tag, it doesn't put it out as the less than symbol. It converts it to the ampersand LT semicolon. Does that make sense?
Yeah.
Same with greater than. It would take the greater than and turn it into ampersand greater than semicolon. Which that means is rather than taking the code and putting it out literally, which is what the triple bar does, it converts that to entities so that the code doesn't run. So that means that the double bar prevents that code from being run, whereas the triple bar allows it to be run. So the only case where you'd want to use, so in general, we want to use the double bar to prevent XSS, prevent them from running code, versus the triple bar would be if you, for some reason, need to allow them to put code into your website. And that may be things like if they're writing a blog post, you may want them to do some amount of formatting on that post, such as doing things where they mark certain text bold or italic or underline, change font sizes and things like that. Then you may need to have them have the ability of giving you HTML code. That's the place where you would use the triple bar. Does that make sense?
Yep.
So if you expect HTML from that, then I would use the triple bar. If you don't expect HTML, which should be the norm, then it would be a double bar. Okay. Does that kind of clarify some of the differences between the triple bar and the double bar?
Yeah.
Are you starting to understand why we do that? Why that double bar exists there and why we don't use the triple bar as much?
Yeah.
Yeah.
So that's one way to block these attacks.
Mr. Smith, I just have one question. What do you want us to post for the attendance today? We didn't really say anything.
It's in the post. It's on the forum on Inside Ranken.
Oh, it was on page 2, and I'm like, where the heck did it go?
Yeah, go back up to the top of page 1. So, actually, I need to switch this. So, one example we have here, and this is kind of putting it more real of how this might look normally. Let's say we have a user here, and they're going to post, right? And they're going to send their text is this script alert 1 script, right? So if this script were to run, we would see a pop-up show up with 1 in it. Does that make sense?
Yeah.
Right. So they're going to send that in as their comment text, right? So they're making a comment. They're going to submit that here. It's going to get inserted into the database. If we're not sanitizing inputs, it'll get submitted exactly as that, which really we should probably escape it at that point, right? And change things like the less thans to LT or the greater thans to GT, etc. Things like that potentially. But it gets put in verbatim, and then we pull it back out of the database, right? So we do a select. It's still like this. It's still a script. We then drop it literally into the page, and guess what? The user reads our comment, and they see alert pop up. See that?
Yeah.
And that's kind of where that looks, but in reality, it's usually much more malicious than that. And to the point that if you can get an XSS attack working, you can literally steal accounts oftentimes. Getting their credentials or being able to log in as other users is not an uncommon thing. So I know that one or two of you started looking at logins yesterday, and you remember that you implemented those with cookies?
Yeah.
So cookies are this kind of piece of data that's stored locally on the browser. And normally, maybe client 1 can't get access to that, right? So they're kind of somewhat private in the sense that different users can't get access to another user's cookie because they're stored on their computer. Well, part of the problem with XSS is you can violate that security with your cookies, because once you get into JavaScript code has access to all of your cookies. So it can actually do things where it may grab that value, that cookie value, and it could actually potentially send it off to another site. So with XSS, it can be bad to the point where I think, Daniel, you were setting it up with like the user ID, right?
Yeah.
You're grabbing the user ID. The more secure way would be to use a token. Back in the day, we also used to use, if we were working with sessions, we used to do session IDs. Session IDs and tokens are equivalent to your password. If you have it, you can log in and use the site as if you had their password. And those are typically stored in a cookie, so if you can get access to the cookie, you can send it off to somebody else. So they post this malicious website, and it's not going to be as simple as just alerting. It would actually grab your password, grab your token, send it off to another site. Attacker can now buy things as you, right?
Well, obviously for a limited number of time though, because that token expires at some point.
That's part of why we limit that time, right? You don't have to limit the time on the expiration. For instance, I think you saw the default expiration is never, right? It never expires. So if you have a token that never expires, you can steal that token and use it forever. If you have a token that expires after 24 hours, then the attacker that gets that, they've got 24 hours to use it, right? So yes, putting an expiry on it helps, but it's not necessarily hard to automate that process where you can say, okay, well, I've only got 5 minutes, but an automated, if it's sending off to a server, the server can automatically go and use it as soon as it gets it. Does that make sense? If you don't have a user involved. So this idea of XSS is really, really serious, and that's the reason we have a lot of different approaches now to deal with it. And some of these examples you may notice comment.php, right?
Yeah.
The way that the simple ways to kind of dealing with user data and such, and the way that because PHP, we kind of started seeing these attacks most, really didn't have a lot of ways to defeat this. So XSS and both XSS and Sql Injection, both of these were things that we saw really commonly with PHP, because developers just don't have an idea of how to prevent it, and none of those mechanisms are really built in. So that's one of the reasons that we're using tools like Connects and we're using handlebars, is because there's some built-in features to avoid cross-site scripting. Cool?
Yep.
Okay. So we kind of talked about, we can do validation on the front, on the client side. We can do validation on the server side. In reality, we want to end up doing validation on both sides. And there's the point being to get the best of the both worlds. There's a really good Stack Overflow answer here about why that is, and a good explanation of how those things fit. The gist of it is that you want to get better feedback. and dealing with a variety of issues. So I'd recommend read that on your own time, comment on it, discuss it, because it's in perusal. Because it does give a really good explanation of what the benefits of both are and the reasons behind it. So what I want to talk about here, and this is kind of the rest of the class, is the main focus is going to be about a tool called Joy, J-O-I. So we're going to use this to implement our server validation, right? So at the moment, we've already done some level of server-side validation, but we've done it with like if-else statements, right?
Yeah.
And you can continue to do that. And there are some benefits and there are some things that you can only test that way. So for instance, testing that the username is unique, that's still something you have to do with your own logic. But there's a lot of common sort of problems that you can solve using this tool called Joy, and that will actually keep your code so much simpler than what it is right now with just if statements.
Is there a happy as well? I remember seeing that package.
There are two packages out there. There's Joy and there's an @happy_joy. The happy is it's a large framework of a bunch of different pieces that you can use with Node. It's not really something I want to go over here in this course. You can look at it if you want to. If I remember right, it's a lot of different pieces, but if I remember, it's almost a replacement for Express, almost an alternative to Express. But Joy has been kind of integrated as part of theirs. Now, when I was looking at Joy a year ago or so, and reading up on things, it had seemed that Joy itself was potentially going to be deprecated, and that would be replaced by Happy Joy. But in the past few months, there's been movement on the Joy platform itself, and now it seems that it's going to be maintained. So that's where we're going back. That's where I'm going to just go over Joy. But Joy and Happy Joy at this point are actually basically the same thing. Cool?
Yep, thanks.
Okay. So I'm going to just use Joy, but they're very much the same code. It's just one was kind of taken under the wing of the Happy project. Okay, so if we look at npm and you look for Joy, you'll find this. So you'll see the most recent version was published about 2 months ago. Just yay. Which actually puts it up to the same version that the other one was at. So this is at version 17.2.1. If I look at Happy Joy, if I can even find it, there we go. So Happy Joy is now the one that's been deprecated. So you see Joy is leaving Happy organization and moving back to Joy. So sometime within the last year or so, it kind of they deprecated the original Joy package, decided to move over and kind of join this Happy organization, and now they've decided to move back. So there's been some kind of transition back and forth there. So there's not too much information here on the website itself looking at Joy. But what you can see is there's a link to their website. You see that?
Yeah.
Link to joy.dev. So if we follow that, you can actually find out all the documentation for Joy here. And so what it is what they call it schema description language basically what you can do is you can define what we call a schema for really any JavaScript object, and then validate that an object matches that schema. So we can use this for a whole lot of things. Whether the main one that we'll look at today is validating our REST API inputs and making sure they fit a certain format. But you can really use it for all sorts of things in terms of validation. If you've got a JavaScript object, you can validate it with Joy. So that means it can be used for data that's coming in from almost any source as a useful tool. The documentation, you can go into API, I think getting started takes you to the same place. So they've got an example here. You can kind of read up on the basic usage of it and read further on all the different pieces that go into using Joy. So if you do want to use this, obviously the first thing to do with working with a new package is you want to install it. So you're going to say npm install Joy. That will now be in your package.json listed as a dependency. Now we want it to be a regular dependency, not a dev dependency, because this will be something that is actually part of your application. Okay. So the general recipe for doing validation with Joy and other things is, first of all, you're going to require Joy. Just like you do with any package, you're going to require it first. Then you need to define a schema. The schema defines what kind of structure does it have to have. And then we can use that schema to validate the request body. So we can say, is it valid? Is it not valid? And Joy will give us some errors to telling us why it's invalid. And then finally, we can send those, if there are errors, we can send those errors back to the client. So that's the general structure, those 4 steps. So that's what you'll see anytime you use Joy. Questions on that? So a schema in many senses is very similar to the table schema that we've defined in Sql. And we can define some very similar things, but it's actually more advanced than even what you can define in Sql in some ways. So let's look at how we might use this with a login page. So I've got, first thing I got to do, remember, is require the Joy package. So that's going to be up there in my imports. And then let's define a route. We'll call it login. Okay. So API app post login. This is the route that we're going to get to when we try to log in, right? And so our login form is going to have 2 fields. It's going to have a username and a password field, right?
Yeah.
Right.
Huh?
I said right.
So what I want to do with the schema, first thing I want to do is I want to define that I have an object. So that's where I'm saying joy.object. So that starts here and ends there. So I'm saying I'm defining, my schema defines an object. And then within that object, I've got kind of curly braces here. I'm specifying the properties that should be there for this object. And implicitly in there, I'm also saying that the object shouldn't have any other properties. It's only allowed to have the username and the password properties. If it has anything else, you're going to get a validation error. So for the username, I kind of start with this username colon, and then I define what are the rules for the username. So for instance, here I'm telling it, similar to I said this is an object, I start by telling that the username is a string, and then I can add additional constraints on that string. So it has to be a string. That part has to come first. And then we can add these other parts in any order. So alpha num, that says that the username has to be alphanumeric, which means that you can only have letters and numbers in your username. You can't have any other characters. There is a way to specify that as a regex to be more general and allow some special characters, but that's a very simple method to just say letters and numbers and nothing else. Next thing we're saying is min4. That says it has to be at least 4 characters long. Max 20, so our usernames can't be longer than 20, and they're required. So all of these pieces here impose some constraints on that username string. Does that make sense?
Yeah, so this replace the if statements you would use before?
It replaces a lot of the if statements. Well, it won't replace all of them, but it will replace many of them.
Yeah.
So rather than needing to write an if statement to check each of these things, maybe check if it's a string, check if it's alphanumeric, check if it's this long or that long or required, that can be all kind of bundled in here and defined. So we're defining what rules does it have to follow. Similarly with the password, we're going to say that the password has to be a string. It needs to have a minimum length of 8. One of the things you'll notice in there is I can add a min without a max, or I can add a max without a min. Those are, you don't have to have both, right? You don't have to have both a min and a max. You can have one or the other or neither. So here we're saying the password has to be at least a length of 8, and it's required. So those are my requirements for the username and the password. So what all this does is defines that schema, which I can then go use to validate the data that's been given. So the data that we have coming in is going to be from request.body. Cool? So that's the data that's been either submitted via form or submitted potentially via some sort of JSON object, like you might set up with Postman, which is actually how I'm going to test this, is with Postman. And then once I've got the data, once I've got the schema, I can then validate the data. So in order to validate the data, you write schema.validate and then validate wherever you want to validate. So in this case, we're validating the request.body. There's a synchronous version of this as well as an asynchronous version of this. This is the synchronous version where we're getting the result back as a val object. Okay, and we'll look at that in a minute because I want to let you see, what comes back as the result of doing the validation. Okay. So I've got this written up as a code example. So I'm going to pull that up in VS Code here. So it's a very simple server that I've got set up. You'll see I'm using the Express app. You'll see that I've already hooked up some...
Can't see your code editor.
Okay. Let me switch the sharing so that I'm switching my screen. So I forgot I had to set it up to share just Chrome while I was doing the videos and such. Okay. Can you see my screen now?
Yeah.
Okay. So basically a lot of this will be the same code we just saw on the slide. I'm adding some additional pieces in there to make this an app. So I've got an Express app. I've got a URL parser and for handling if I were to submit as form data, and I've got a JSON parser to let me submit it as JSON. So here's the actual route that we're looking at. Okay, so I'm going to start up the server, npm I, get my dependencies, and I'm going to start it with nodemon. Okay, let's pull up Postman. So this is running at localhost 3000, and the path to it is login. So I'm hitting up localhost 3000/login, and this is going to be a post request. So first things first, I'm going to try it without adding any data in there, and this would basically simulate if I submitted a form without entering a username or password, right? Okay, so if I hit send, what I've told it to do is do two things. I've told it to log the data that we sent, as well as log the response that comes back, data val, and then I'm just sending the validation back. And so this is just to see, what is the response that we get in a variety of different scenarios. So for instance, I can see that what I've sent it right now is nothing. You see that? It's an empty object.
Yeah.
Okay. So I've got an empty object coming in, and once I do the validate, here is what Joy produces. So Joy comes back and says, okay, so the value is empty object. This kind of repeats or echoes the value that we gave it, and we'll see why that's here in a later example, because this is helpful. But under error, you can see that it tells us what went wrong, right? So there's an error property. It's got this, you can kind of see username is required. It's an error. If I go back to Postman, I think I can get a better view of it here. So let's look at what came back. So we've got value is empty, error. We've got inside of error. We've got original, and we've got this details. Details is all we care about here. So details gives us details about the errors. And you'll notice that details is actually an array, right? So potentially you could get more than one of these things back, more than one error. So in there, error details, we've got, for instance, in the message, it says, well, the username is required. See that?
Yeah.
So that's the error message that it spits back. We're saying the username is required. In there, it also has the path. So it says, well, what field is invalid? So if we were sending this back to a form, we could use this path to determine, okay, where do I need to display that error message? So I need to display it with the username field. It tells us what kind of error it is. So for instance, it's an error that the field is required. So we know which field it is. Similarly, we can also get kind of that context also tells us. So we know the username is missing on the required validation kind of constraint. Okay, so that's username is required. So what do I want to do to get past that? I probably want to give it some data, right?
Yeah.
So let's say I go over to body, or actually maybe I just stay on params, because I think I can just do this through params. Let's say I set username, and let's set it to test, and let's see what happens. So if I set it to test, something's not right, and maybe I can't pass. I don't think I can pass this as params. I need to pass it as, I think, body. Yeah, that's what I want to do. Yeah, so I don't want this params that puts it in the URL. I want to put it in as body and form URL encoded. So remember we added that URL encoded body parser at the top. So that deals with that here. So I'm going to do form encoded, username. Let's set that to test, and what we should see is that the error message has changed. Cool. Okay, so we gave it a username, and now it's happy with that, right? It's happy that we've given a username, so the message has changed to password is required. Do you see that?
Yeah.
Now, if I look back at some of my requirements, you remember that I have some other requirements in here beyond just that it's required, right? So we should probably go back and see what that does as well. So alphanumeric, min, and max. But let's put the password in there. So password is password. So we get test and password. And now it's actually happy with it. And because it's happy with it, you see that there's no error field in the response. Do you see that?
Yeah.
So it only gave us the value. So that's what you can look for, is if you're calling validate, you say, is there an error object or not? If there is an error, well, then it didn't validate. And if there's no error, then it did validate. Okay, so we can break some of those rules. So for instance, with the username, I said that it has to be alphanumeric. So how would I break that rule? How would I make this not alphanumeric?
Give it like a $sign or something.
Okay, so test $sign. Okay, so now it says the username must only contain alphanumeric characters. So we get this error message and we can show that to the user, potentially, right? Cool. So that's testing its alphanumeric. I could also shorten this and say TE, right? And it's going to tell me that it must be at least 4 characters long. Great. So it checks the minimum length. And I could make it a much longer. Try it. And it's going to tell me that it has to be 20 characters or less. Paul, I see your light coming on, but I don't hear you. So we can test a few different things there. Let me put this back to test. We can try the password and hit send. It'll tell it the password has to be at least that long. So with a relatively minimal amount of code, I can actually test for quite a few different things. Do you see that?
Yeah.
So again, all of this stuff, all of these checks that we just saw here, we've already looked at how to do that. You've already seen how to do that with if statements and potentially with regular expressions. But this can make your code a lot shorter and a lot easier to work with by defining the schema and then just validating the schema to see if it's good or bad. Now, one of the things that we can't validate with the schema like this, as I kind of mentioned previously, you can't verify unique constraints this way. So if your username has to be unique, or your username has to be unique, or like your email has to be unique for creating an account, or things like that, or you need to check that the user can't purchase an item multiple times, those are things you can't do with the schema. Unique constraints, you'll still have to do that with accessing the database, because obviously you need to know what's in the database. You need to know if that row exists in order to check those kind of things. So it's not a substitute for all of your validation. It's just a substitute for most of your validation. Cool?
Yep.
Okay. So let's build on this a little bit. So I built the logic to validate it, but I'm not really doing anything with that result yet. So let's see what I could do with that result. So one thing I might do is I might say, well, let's say, is there an error? So let's do the validation and then immediately check if there's an error. So if there is an error, I might say val.error. Okay, let's figure that out. And then I can kind of extract, or if there is an error, I can log the error message, and then send that value back. So if I try that with, I've got Postman here. Let me try that as login 2. You'll see it kind of sends me the same response. But if I look at my console, you see I've logged the error message. So maybe rather than logging the entire thing, I could say, let's pull out just that part. Do you see how I'm pulling out just the error message specifically? This line of code?
Yeah.
So val.error, right? That gives me the error object. You saw details had information about the individual errors that occurred, but you remember that details was an array, right? Details was an array. So what I then do is I say map kind of transforms that array from an array of errors to an array of strings, because all I care about is the message in there, right? So if we look back at the schema, you see how, okay, I've got this array of things. The only thing I care about right now is just the message. See that? So that's where my map comes in. I'm saying I just want the array of messages, not the array of errors. And then finally, I join them. So join takes an array of strings and puts them together in a single string. So this will take all of those errors. If I had, say, 3 different errors coming back, that would join them together into a single string and put a new line character between each of them. Cool. Troy, did you have something to say?
No, sorry. I keep hitting on the keyboard.
It's no problem. No problem. So you see what I'm doing there. So if there is an error, I'm going to log it to the console and just the error and then send it back. There's a lot of different ways that you can handle this. You know, you could take the individual information out and kind of send it back the way you have been. So that might be one example there. And then I'd say, well, if there's no error, right? So if there's no error, then we can then go look at and deal with it and say, hey, is this the right username and password? And, you know, send back the right response there. Cool?
Yep.
So you kind of hopefully see that doing this took what would have been probably potentially maybe at least an if statement for each, but probably a bit more than that to give them the different error messages, because you also notice that it gives you a different error message with each of the constraint violations. So it doesn't just say invalid username. It says, well, the username's too short, or the username's too long, or it's not alphanumeric. So it's more than just saying it's invalid, right? So if you were going to just say it's invalid, well, you could do that with 2 if statements. But if you want to be more specific, you would potentially need to write 6 if statements just to cover those bases, right?
Yeah.
So I've done that in one using this tool and kept that very kind of easy to read. Okay.
What about special characters?
Special characters, if you want to allow them.
Or require them, like maybe at least 2 of them. Is there a way to put that into the joy?
Yeah, so then you would need to use some regular expressions to do
Oh, okay.
You would need some regular expressions to do that. Which Joy does have a method. You saw there's an alphanumeric method. There's also a regex method that you can give it, and then it'll also check that string matches that regex. So we can look at that when we get back to our example, for instance. Back to a registration example, for instance. So we've got those rules. Further thing I can do, you saw that what we were doing so far, we were dealing with this as the synchronous version, as I said, schema.validate. There is also an asynchronous version of this validate method. It's called validate async, right? So validate async returns a promise, which then you can await, right? Remember we talked about the async await syntax, right? You remember to use the await async syntax, you need to mark the function as asynchronous. See that up here? So we can await the result of it, And we can put this, and then remember, anytime we have promises, we generally need to put this in a try. Well, what this does is if you use the asynchronous version instead of the synchronous version, it throws an exception instead. So if it fails validation, it actually throws an exception, which then you can deal with in your catch. So it also reduces maybe another if statement in there, potentially, at least in the main body of your code, if you use the asynchronous version. Do you see that?
Yep.
So I typically will use validate async and not validate. But you can use one or the other, either one. There is some benefit potentially if you want both the value and the error parameters, which you saw come out. If you use the asynchronous version, you only either get the error or the value. So if it succeeds, validate async will end up returning the value, but if it fails, it doesn't get there. You don't get the value, you just get the error. Cool. So the next thing I can do, we kind of talked about, okay, so you can do that asynchronously. We saw that value that comes back. Well, that value that comes back, with the synchronous version, it's the return value of the function here. So for instance, I'm calling validate async, and I say, well, data equals await, blah, blah, blah. So this actually returns that value parameter. Well, where that's helpful is that value lets you also sanitize data. So not only can Joy do validation, it can also do sanitization. So for instance here, you see I've got the trim method in there.
Yeah.
So in addition to checking that all of this is valid, it can also trim the string to remove any white space from the beginning and the end. And the helpful thing in there is it'll also make sure that that happens typically before it checks the length. Because oftentimes people will make the mistake of like, well, I checked the length and it was 20, or sorry, it was at least 4 characters long, right? But it was a T in 5 spaces, right? It was a T in 5 spaces. So before I trimmed it, it was long enough. But after I trimmed it, it wasn't long enough. Do you see that?
Yeah.
So putting that trim in there can help with things like that, not just cleaning up spaces from the beginning and on, but also making sure that you do the trim before the validation happens. So let's say I try this version. I'm going to try 3 and 4. Try it with and without the trim. So login 3 is without the trim in place. If I say tests and password, right? So it's happy there. Well, is it not? It's not happy. What did I mess up? Username, password. Why is it a bad username, password? Oh, because I need to put admin and password. Got it. Okay, so that passes validation and gets through my other check. But if I were to say that's going to fail. If I were to say, so admin and password is a good password, right? I would expect this to work, right? As well. If I put spaces before my name. See? Or if I put spaces after the name, I would expect that to still give me, you gave me the right username and password. But look at what happens. It says username must be alphanumeric. See that?
Yeah.
That's not right. We should just trim the spaces off the end. So if I add in that trim, then it works. Then it takes the spaces off the beginning and the end and says, okay, cool. You got the right username and password. Does that make sense? Why that's kind of...
I'm not getting what's the difference between login 4 and where's that coming from again?
So if you look at the code here, so login 3, right? I don't have a trim in there. So
Okay,
no
I
trim.
got it.
Login 4 has the trim. So the other thing I'm doing in the 4th version is I'll take the, rather than just what you see, I'm putting the request.body, I'm putting it into data, but then I'm overriding it, I'm replacing it with the result of the validate async. So because what comes back from this will be the trimmed version, right? So what's in request.body is untrimmed. What returns from here will be sanitized. It will be trimmed. Cool. So like in this version, you saw how I was just saying await async. I wasn't saving the value. If you put a trim in there, that wouldn't actually keep the trimmed value. Does that make sense?
Okay, so the async await there, that's a promise for an object. That's the username and the password.
Right. Yes.
Okay,
Yep.
and why again? What's wrong with this? Where's the advantage of doing that?
The advantage of trimming it?
No, I get that part of it. I'm talking about async and await, just because it takes time for it to submit and go through the validation.
So in theory maybe, but it really doesn't. All of that's CPU bound, so not really. The main advantage of using the await async over the synchronous is that it comes back as you just get the data or you just get the error, right? So you can handle the error with a try catch instead of, you see how I had to check the error? I had to say if val.error. The problem is it's easy in this code to accidentally forget the if, and then now you're letting invalid data through. Does that make sense?
All right, so it's just easier syntax, and it just helps you out there.
It's easier syntax, and it means that you have fewer problems because it's an exception instead of it's just being a result. Does that make sense?
Okay, yeah, I see that it's easier.
Okay, so it's the main part is it becomes an exception. So we've got that, and that's how I would deal with trimming. So we could then maybe enhance this a little bit. We've talked about login. Well, what about registration, right? So if I'm talking about registration, I can add in all of these constraints and kind of validate it. And that's where this becomes much more powerful, especially as you have larger forms. With a simple password, username, password field, it's helpful, but it's not necessarily a big deal to write it as if-else statements. But when you're talking about a large registration form, you've got a lot of data, a lot of conditions you need to check for. This can be a lot easier to implement. So if we look at this form, we've got a username, we've got a new password, confirmed password, email, given name, and family name. We can kind of walk through, so what are the requirements I've defined here, right? So the username, I've defined it as required. It's going to be trimmed. It needs to be alphanumeric, minimum 4, max 20. Typically your requirements for login, there should be the same as they are for registration. Does that make sense? Typically you want the same requirements both places. With the password, I'm saying that's a string, it's required, we're going to trim it, and it's got a minimum length of 8. Cool. With the confirmed password, then I'm also saying that it's required and trim, and I'm adding this special thing to it. So I'm saying .valid. So .valid typically says that it needs to be one of these values that I've specified. So you usually give it like an array to say these are the values that it can be. In here, I'm giving it a very specific value. I'm saying it has to be joy.ref new password. So what that says is that it has to match, the password has to match the new password field. Does that make sense? So this implements that check, that the new password has to match the confirmed password has to match the new password. So you can do checks this way as well. I will note that check for ref, if you look at the example on their website, is actually wrong. They have a different syntax. They just put joy ref password in here, and that, as it turns out, doesn't work. So this is one thing where they're, as far as how you use ref, their example on their introduction is actually wrong. That's the way you would do it. Email, string, email. Notice that there's a special other constraint in here. So we saw alphanumeric that I was using on the username. There's also a .email, and that will make sure it's a valid email. So things like checking the @ sign there and the .com, etc. is there. That's all you have to do to validate that it's a good email.
And Mr. Smith, when you're using a regular expression later on with this, there's going to be some redundancy in that, because I would assume an email is going to check for a @ sign and a dot something.
Well, I don't need to. This has the regex built in, so I don't need to write a regex to validate the email additionally if I'm doing this. Do you see that?
Okay, it would just be on passwords mostly.
Yeah, on passwords if I want to check for other things like special characters. But for testing emails, for instance, that's all you have to do. You don't have to, you can provide a regex, but you don't actually have to provide one to check for an email, because that's such a standard thing. It's already built into Joy. So you can say, well, let's test that it's an email. Let's make sure it's required. You'll notice I have an additional method in here. So I'm doing the trim, but I'm also doing another sanitization step, which is this lowercase. Do you see that? So emails are supposed to be, and they are, case insensitive. It doesn't matter if you type in as lowercase or uppercase, it still should get to the same place. Does that make sense? So for convention, we will typically take, it's good to take your emails, if somebody gives you an email on a registration form or wherever, to take that email and make it lowercase, so that you don't later run into some part of your code that treats uppercase and lowercase differently. Do you see that? So if we at the front end make it lowercase, then later on we don't have to worry about the case mismatch problem. Cool?
Yeah.
So that's a general good thing if you're, sanitizing your inputs. Let's look at the name. So we've got the given name, the family name. You'll notice that I've said it's a string. I've said it needs to have a minimum length of 2. There's no maximum length here, and there's no, and I'm telling it to trim. Now notice one thing that's missing there. There's no required, right? So if you don't include required, that just means it's optional. So in there with these constraints, I've said that the given name, or their first name and their last name, are optional. Do you see that?
Yeah.
So that's all you have to do to make something optional. You just don't include required. So because by default it is optional. Okay. So we've seen a few examples there. You can play around with the code, because I've got that endpoint for register. So you can play around with that in Postman if you want to see how that works and see some of the different errors message that you might get. You kind of go over some of the methods that are available in the API. The API for Joy is pretty big, but there are only there's only some of those things that you actually were probably going to use on the regular. So the first ones is the data type methods. So we've seen joy.object, we've seen joy.string. Joy.object says it needs to be an object. There's an array. Joy.array says it needs to be an array. Says it needs to be a string, a number, a boolean, or anything. Any rule that you create with Joy needs to start with one of these things. You start by saying what data type is it, and then you add additional constraints. Is that cool?
Yep.
So I might start by saying that the price needs to be a number and then add things to it, right? Be more specific about what kind of number it is. Or with the strings that you saw, saying that the string needs to follow these requirements. So basic common string requirements that you'll put in is required to say that it's required. If you leave it out, it's optional. You can put in a minimum length. You can put a maximum length. You just do that using those 3 methods. It doesn't matter really what order you chain them in. As far as I can tell, it seems to not matter which order you chain them in, as long as you put the data type first. Other requirements that you can impose on strings, you saw we can impose it as, say, it has to be alphanumeric, just letters and numbers. We can say that it has to be an email. We could say that it needs to be a URI. So if, for instance, maybe users are giving you a link to their resume, for instance, you might want to validate that that's a URI. If it's a link to their resume or their portfolio or wherever else it may be, maybe it's a link to where to download some music or other files. So you can validate that it's a valid URI. You can validate.
Wait. URI.
URI.
I thought it was a URL.
So there is a URI and there is a URL. They're both very similar. They basically follow the same syntax. So a URI is more general than a URL. Okay, so every URL is a URI, but not every URI is a URL. Okay, so URI is a subclass or superclass that contains URLs. And basically the things that don't fit into URLs is typically things that just start with HTTP or HTTPS. Does that make sense?
Okay.
So a URL is generally just starts with either HTTP or HTTPS as the protocol. So URI follows a similar syntax but supports more protocols. So for instance, if you have a file on your system, that would be file : at the beginning, right? That would be a URI, but it wouldn't be a URL. And I think part of the distinction is URL is typically something you can get to from the internet, like anybody can get, or most people can get to it from the internet, versus a URI is something that you may or may not be accessible through the internet. Is part of the distinction. So file is one of those kinds. FTP would also be a FTP URL would be FTP URI would be another example of that, where it would start with FTP. If I have a link to a Discord group, that might start with Discord : or if I have a telephone number, you remember the telephone number and the mail to links, right? Maybe from first semester, remember writing mail to?
Yep.
So a mail to link is not actually a URL. It is a URI, it's not a URL. Following? Or
yeah.
Or if it starts with tel dot, that's not a URL, it's a URI. Cool. So a URI is kind of more general. Oftentimes the terms URI and URL get used a little bit interchangeably, but a URI is a little bit more general than just a URL. So credit card numbers I can also validate using this, and it'll actually go through and do, it'll actually check the check digit as well. So when you're looking at credit card numbers, for instance, there's some additional numbers in the credit card number that are actually specifically there to make sure that you entered the number right. So when what we call them is a check digit. So let's say your credit card number is what, like 10 digits long, right?
I thought it was 16.
16? So if it's 16, then I don't remember exactly how many digits they pull off, but you might say, well, 12 of those are the credit card number and 4 of those are the check digits. So you can basically do a calculation on the first 12, and that gives you those check digits. So you know if those 12 don't give you the same last 4 digits, then you have a wrong credit card number. Does that make sense? Things like that. So it does those validations in addition to just checking that it's in the right format. It's really nice. And then if you want to do your own regex, you can add in either pattern or regex. These are just aliases for the same thing. Pattern and regex do the same thing. They're just different names for it. And then you can supply your own regex. Cool. So you've got the basic requirements of required, min, and max. You can also add additional requirements to the format. And these 5 are not the only ones that are out there. You can look at the documentation and find a lot more. But these are probably the only ones that you'll need, I think, looking at what's there. And just kind of telling you about what's available. String transformations, or you might want to use for sanitizing. We looked at trim. Trim removes the white space from the beginning and the end. Do remember that trim doesn't remove white space from the middle. It's only white space at the ends. Lowercase if you want to make it all lowercase. Uppercase if you want to make that whole string uppercase. Or you can do a replace. A replace will say, well, anytime I find this, put this character instead. So for instance, with a replace, you could say, well, find all the less thans and replace them with, the entity symbols, right? Or just remove them. Cool. So your replace can help with sanitizing data as well. Or if you find it, if you're worried about SQL injection, you might be looking for single quotes or double quotes and say replace all the single quotes with 2 single quotes, or replace all the double quotes with 2 double quotes, things like that, to escape different characters. There's also requirements for numbers, and numbers use a lot of the same requirements as strings. So required, you can impose a required, say a number is required. There's also a min and max, but when you use min and max with numbers, that's not how long it needs to be, not how many characters. It's the number that it can be, the smallest and the largest number it can be. So I could say for a number, this has to be between 1 and 500. Cool. You can also say that it has to be a multiple. So maybe it has to be multiple of 3, multiple of 5, or whatever it may be. And you can specify precision. So for instance, if you're taking prices, right, you want those to have 2 decimal places and never more than 2 decimal places. So you can specify the precision as 2, and that won't let them put in a 3rd digit. Does that make sense? For validation. So that's working with numbers. You can also, I kind of mentioned that there's an arrays. The way to deal with arrays, you start with joy.array, and then you do .items, and you can then say, well, what rules do the items need to follow? So for instance, here I'm saying joy array items, and then you see joy number. So I'm saying that this has to be an array of numbers. You see that? If I did just joy array without this, it could be an array of anything. But here I'm saying that it has to be an array of numbers. Questions?
Nope.
Okay. So can you guess what I would need to do if I wanted this to be an array of objects?
Joy.object.
So in here, instead of joy number, I might say joy object. So I could say, let's have an array of objects. So I might say joy array items, joy object, start that here and that here. And then in there, I can specify, well, each of those items in the array need to have these properties. So here I'm specifying an array of objects, and each of those objects has an ID and a name. That's how you can validate arrays. So what did we learn today?
I no longer have to make 8.
You no longer have to what?
Make 8 if statements.
Yes, you have to make a lot less if statements if you use this. You'll still probably need some if statements on the client-side validation, right? Because Joy is strictly for your server-side validation.
Yeah, why don't they make it for both? It just seems like it would just straighten out a lot of stuff.
Because there's better tools on the front end, actually. So a better tool, yeah. So one of the great new tools out there for front side validation is actually part of Bootstrap. So if you look in the Bootstrap documentation, if you go to the page on forms, you see I'm in the form documentation. Technically, yes, you could use Joy on the front end. It's a matter of that there's better tools, is the reason why I say not to, because it's not as good on that front. But when I'm going in here, you see, if you scroll down far enough, you see there's a section on validation. Do you see that?
Yeah.
That's what I would stress that you want to get familiar with. I put a link to this in Discord. That's what I would get familiar with for doing your front end validation. It's actually really nice because it hooks into the HTML attributes and uses those. So if we've got this form down here, you can see the requirements. You see how that instantly gives me feedback?
Yeah.
That's built into Bootstrap now. You can do that with Bootstrap. You don't have to write to do this, you don't have to write very much. You don't have to write very much code actually in jQuery. They give you kind of an example script to hook this up, which this script is written in vanilla JavaScript. But if you kind of go through it and read through what it's doing, it's actually very easy to turn it into jQuery, and it comes into like basically a line or two of jQuery if you use jQuery instead of vanilla JavaScript to hook it up. So it's actually really, really easy. So they're using things like here, you see how it's marking it as good and not. That's actually coming from the fact that it's required here. You see that?
Yeah.
So it's not using any sort of special Bootstrap attributes per se. It is using some classes. So for instance, this feedback here, he has the class of valid feedback, or this one down here has the case of invalid feedback. And we've got no validate that's actually on the form, which is what basically what they do is they turn off the built-in browser validation, but then use the same fields that your browser validation uses. By turning it off, that lets them style it, rather than going through and trying to style all the different browsers to be the same. Cool. So this is what I'd recommend for your front-end validation, is to use the Bootstrap validation stuff. Does that answer your question, Paul?
Yes.
Okay.
Thank you.
So this ends up, I feel comes out easier. Okay, what else did you learn today? So we learned about server-side validation. You learned that you need fewer if statements now.
Learned about attack types and kind of how they work.
Mm-hmm. So I did, towards the beginning of this, I mentioned kind of 2 security vulnerabilities that you want to be sure that you deal with. What were those 2? Different security, different sort of types of attacks.
Sql injection and XSS something.
XSS, short for
cross something.
site scripting. Yeah.
Yeah, that.
Yeah, it's kind of a weird acronym because the cross is it's not C, it's X.
Yeah.
But I didn't make the acronym. That's what it is. So, okay. So that's the theory of it.